Hi, this one is a continuation of the string mass system we solved yesterday on my previous video on how to write this code. And we said the mass to be this value, this is stiffness. You can check out on the description the link to the to part 1 whereby we wrote this script. Today I want us now to do some plotting and some manipulation in-depth. And, and I'll start by defining the plot parameters. We want to plot the graph of displacement against time, then velocity against time. And remember we said this dx gives us the velocity, dx2 gives us the acceleration. And we used dsolve to solve for the value of x, and x is our displacement symbolic equation. Then we converted this symbolic equation to MATLAB function of x, and we stored the results to x fun. We converted the velocity to MATLAB function. We stored the results to x dot dot fun. Then from xt, you can get displacement here, and vt you can get velocity. Basically, this one is velocity, and this one is a displacement. Yeah, I discussed this in my previous video. Please check it out. Now today I want us to concentrate on the plot parameters, and the first thing I need to do is to define the color of my plot. Maybe you can say color. Let me use variable color. I want to use a vector. We usually define red, green, blue. Therefore 236 of let me use by 255, 237 by 255. You can manipulate these values by this means it is a percentage with 255, that is maximum. This one is R green blue. Next, I want us to define units of my graph. I'm going to use normalized. This means zero. When zero means 0%, while one means 100% normalized. The line width of my graph, of my axis, the line I'm going to draw, I'm going to use the 2. The font size, here is where you define the parameters. I'm going to use a 22. Then the figure position, I want to have a very big figure. Therefore position underscore figure. I'm going to define using a vector. One, you need to define the distance from the left, distance from the bottom. I'm going to use 0.1. Then horizontal length 0.98. Then vertical length 0.8. Yeah, it's not a must for you to define these parameters, but for me I like controlling them. Then for the title graph, my title will be, this one will be displacement, will be displacement and velocity. I'm going to use same graph to plot those two graphs versus time. Okay, then for the, I'm going to label my graphs. I will have x label. We just have one x-axis, therefore x label underscore graph. I'm using variables here. I'm going to use time t in seconds. That will be my label. But for the y-axis, we'll have two graphs. We have y label underscore graph 1, because they will have several graphs. For the graph 1, I'm going to label it as displacement in meters, while for the graph 2 here, I'm going to label it as velocity in meters per second. Okay, let's first of all run this code and see what happens. Nothing happens because I've not yet started plotting. I'm just defining my parameters for the plot. Let's now do an actual plot. Plot graph. Plot graph. Let me see. Let's now go here. One, and I want to store the graph in a variable called figure, and call the figure. In the figure, I want to define the color of my figure. Color to be the color I defined, CLR here. I'm using this variable. You can still use the full name if you want to avoid confusion, like that. Then for the units, I'm using units, variable units. If you want to define this, to define them directly here, you can use the normalized here to still work. Then for the position, I want to use position figure. I like having parameters at the one section so that I can manipulate them at any given time without touching the actual code. Then I'm going to use a Plotyy command, whereby I'm going to define, I'm going to use this command here, Plotyy. Let me first of all do help Plotyy so that you can understand Plotyy. Oops, it's supposed to be double Y. Sorry for that. I'm going to use this one, last option here. You can see AX, H1, H2 Plotyy. I'm going to use this type of structure because I want to return the handles of the two axes. I'm going to have two axes, AX, that is for the Y axis, Y1 and Y2, and the handles of the graphics objects from each plot in H1 and H2. Okay, AX is the left axis and AX2 is the right axis. Let me explain this practically by doing the actual plot. Therefore, let me do the vector here. The vector is axis graph. Axis, I want to use that axis graph as my first handle. Then I want to use line 1 and line 2. Okay, line 2, this to be equals to, I have a new keyboard. I've not yet mastered these values. Time, it needs time on the x-axis. Then for the y-axis, I'm going to use displacement, that is x of t. This one is a first graph, x-axis time, y-axis displacement. Second graph, time, y-axis velocity, like that. Let's run and see what happens. You can see I have two graphs here, this and this, and I'm using the same x-axis. The reason why I've said time and time, you can see the same x-axis, but for the first graph, that is x label for the graph 1, y label graph 1, I'm using displacement, that is xt. For the y label graph 2, I'm using velocity. And we said velocity is a derivative of displacement. And I'm using plot y so that we can have two plots under the same figure. Therefore, the plot of the first line, that is, let me go back here. This one here, blue corresponds to the first axis, red corresponds to the second axis. Therefore, this line L1, it will always return the first axis, that is the xt. It will always return xt, meaning it will always return the blue. Blue, the first one, this is the first one, this is the second one, while L2 will always return the second one, that is a V2. Okay, axis graph. Then the axis is the actual axis here. You see this value here. Right now the axis is 0.02 on this side, but on this side is a 0.2. These two values will be returned by the axis, whereby if I say axis graph 1, and I'm going to return this value. When I say axis graph 2, I'm going to return the red values. The reason why we say, let me do again here, help plot y. The reason why, you can see here, ax1 is the left axis and ax2 is the right axis. If you want to get those axes, you use ax1, ax2. These are just variables. You can use any. I can say x, x, x. These are just variables. Whatever you see inside here is a variable, but whatever you see here, these are now the functions in the MATLAB. Therefore, let me go back here and now start to manipulate this one, because this one doesn't have any information. We need to give label. We need to give this width. Remember, we defined the width, some title. Let's do some now manipulation a little bit. Okay, the first thing I need to do is on the first line, I want to set some parameters. I'm using command set where in line 1. You can see on the screen how to use set. H is the hurdle for the line 1, that is line 1, that is xt. I want to set that one. I want to set what? First, I want to set color. I want it to be black, K for black, and line width, the line width spelling here to be a line width variable. Okay, to be line width. Then I want to say font size. The font size to be what? To be font size. Yeah. Let's see what happens when I run this. You can see now the first line L1, this one black. I see line width to be bigger and color to be black. Let me now do the same thing to line 2. I'm going to use line 2. I want to make it red. If you run, go here. Let's do run. Okay, something is, no, I've not done something here. Let me see what I have missed. Set line 1, line 2, color. Yeah, I want to see line 1. Yeah, should have line width. Yeah, I don't understand. Let me see on the MATLAB. Okay, something is not okay. On line 40, set line 1. Okay, color. Let me see. Unrecognized property font size for class line. Okay, font size. Let me see the spelling for the font size. Font size, font size, font size. Unrecognized property. Basically, they are saying the property defined is not recognized. This happens whenever there's some scripting error. Line width, font size, font size. Okay, sorry, my bad. For the line you don't need font. Whenever you use the command for the set, whenever you're setting the line, for the line you don't need font. I apologize for that. You don't need this one here, this section here, because line width is just enough. You don't need these items here. Those ones you don't need them here. Okay. Also, I don't need this. You only need line width. That's enough. Yeah, I can see now the width. I don't need font. Font is for the title, and the titles is for the font, but for the line you don't need the font size. Okay. Then I want to set axis. Now for the axis is where you need the font size. Okay, graph 1, the first graph. I want to set the y-axis color to be, also I won't use red, I won't use black. The symbol for black is K. Line width, to be line width. Then for the font size, here is where you define font size to be font size. Okay, let's see. You can see now this becomes black. Here. This becomes black also. Let me go back to the MATLAB here. Okay. Line 42, let's see. Unrecognized property, line width. Okay, spelling. It's about spelling. Yeah. Okay. Now you can see it becomes, on this axis we have bigger font size, but now this one is still small. We need to change. It's good whenever you are running to have this open, so that the errors you can see them here. Then on to search for the graph 2, the rightmost graph. Remember we said axis graph, this one here, returns what? Either graph 1 or graph 2. I'm using 1 and 2 for left and right axis. This one I want to use red. Yeah, now becomes red here. You can see, becomes red. Let's now do the labeling of X label. I want to label X axis of axis underscore graph 1, the hand 1, to be X label. Let me just copy whatever you used here. X label graph, control copy here. I want to use it here. Control paste. Then I want to use font size to be font size. I want to also to label Y and y1 and y2. Therefore, I copy this twice onto label here, y label and y label of graph 2. Here is 2. I want to use y label here and y label here, spelling here. Of graph, I'm using graph 2. I defined graph 2 and graph 1 here. Here, x label, spelling also. I'm using y label graph 1 and y label graph 2. Y label graph 1, y label graph 2. Let's see. You can see now displacement on first y label and velocity on the other label. That's how you do the labeling. Then we are missing title. Title can say title underscore graph. If you want to see the title, run, see the figure, the displacement and the velocity versus time. If you want to change the color, you can use maybe blue. Title here can say color to be maybe blue. Then you can say maybe, yeah, maybe that's enough maybe. Displacement, velocity versus time here, B for blue. Next, we need to do some, I want now to set the axis. Lastly, I want to set this axis here. I want to set these values. I can set this. You can see on this one, they are extremely on the graph. This one's also, this one are extremely on the graph. I want to set those axes. We can call that one maybe you can say axis manipulation. Let's see. Okay. First thing we say that on the axis here, axis graph, this one returns the axis of the graph. This one returns the line. On this one, I'm going to use only the axis because I need axis. I want to manipulate the axis only. Therefore, I want to get limit of maximum limit first of the displacement. I want to get this value first. It is a maximum absolute value of xt. This command will return, max returns the maximum value of displacement. Then I want to add a little bit. Let me first fold like this. Basically, let me go back to the graph. Basically, if I use this maximum value, I want to have a small space above 0.2. Therefore, I'm going to use just a small value here and say maybe a 0.05 multiplied by the maximum. I want an absolute value of displacement like that. Okay. Therefore, the y limit, the y axis now, ylim command. If you do help ylim here, let's see what happens. You can see ylim sets or gets the y limit or y limit mode property for an axis. I want to set the limit on y axis. Therefore, I'm going to use ylim of which of axis? Graph 1, the first graph. I'm going to use a vector. I want to use from negative to positive. Therefore, I'm going to copy this here from negative, this one here, to positive. Then I can use semicolon. If you run, okay, what happens? 51. Invalid expression. Okay, we are missing this. If you run this now, We can see now on the first one here, I've defined limit. On this axis, I'm defining limit, but I've given some amount here, 0.01, to have some amount, a minute here. Let me go back to the initial. Let's use initial value how it was. It was 0 yesterday. Yeah. Before I define this, let me do something here. Before you define this, let's see what happens. If you run this, you can see the graph of this value starts at exactly 0.001. It is touching the axis, our axis here. This happens when the initial velocity is 0. This one is when the initial velocity becomes 0. Therefore, the initial velocity becomes 0. This one becomes the maximum. The reason why, at the initial velocity 0, we are getting the displacement being maximum. But I want to have some amount here on the axis. Therefore, I'm using this y limb here. If you remove that y limb, see, I'm getting some amount here on the axis, and my graph line 1 doesn't touch the limits. Okay, same case applies to the. I'm going to copy this and paste so that we can use velocity v maximum of v. Just change here of v underscore t v underscore t, yeah, of graph 2, not graph 1. Now it is a graph 2. If you run, you can see now you have some amount, and this one is not touching here. It's not touching at all. You can see there's some small gap. That's how you can plot and do some manipulation in MATLAB. In my next video, I'm now going to illustrate how now you can extract the data. After getting these graphs, how do you extract the data that we are going to use to analyze? As you can see, the spring mass system is exhibiting simple harmonic motion that is constant because you don't have damping. What happens whenever you have damping? You see this graph will now start to, the energy will be dissipated out. But for now, the energy is constant from kinetic energy to potential energy. Therefore, on the next one, I'm going to illustrate how you can extract important information here. Thank you, and stay tuned for more.